Hello humans, aliens, and others. Today we're going to be talking about adding and subtracting positive whole numbers. Now it's a bit of a mouthful, but basically we're just talking about adding and subtracting, well, positive numbers with no decimals. So don't be scared by the long title. So remember from last time we were talking about the number line. This is 0. Everything over here is negative. Everything over here is positive. So we can have positive 5. We can have negative 3. Now, let's say I wanted to add negative 3 and positive 5. So if we have a number line, that's actually quite simple to do. Let's start from 0 as always. And, let me write down the equation. 5 plus negative 3. And when we have a negative number here, well, this looks kind of weird, right? Like, what is this? So we generally put a bracket to really separate. So what? We have 5 plus negative 3. Okay, so the number line method means we go from here, from 0, and let's move 5 steps to the right. 1, 2, 3, 4, 5. Okay, so right now we're at 5, and now we're going to add this negative 3. And adding simply, we just look at the sign and we remember, okay, negative just means we're going to the left. So in this case, we just go to the left 3. 1, 2, 3. And where we end off to is the answer. So the answer to 5 plus negative 3 is 2. Okay, let's try another example. Let's try 7. Negative 7 plus 8. Okay. So let's start from 0 again, and let's go 7 steps to the left. 1, 2, 3, 4, 5, 6, 7. All the way to negative 7. And now we look at this number and we see that it's a positive, right? So now let's go 8 steps to the right. 1, 2, 3, 4, 5, 6, 7, 8. Oh, we're over here now. So that is just positive 1. So this is equal to positive 1. So this is addition. And when we have a number, let's say 1, and we add another number to it, this number is called a sum, S-U-M, sum, and both of these are both called the addend. You spell that as A, D, E, D, and D. It's called the addend, so that's just the very fancy way of saying the numbers that you add together. We don't usually say the word addend, but if you want to sound fancy and smart, you can say addend. Let's try one more example. Let's do negative 5 plus 5. Okay, so we start from 0. 1, 2, 3, 4, 5. This is negative 5. And let's go back. 1, 2, 3, 4, 5. What happened? We're back at 0. So remember, if you have a number and you add its positive, you always end back at 0. It's kind of like, if you're taking a walk and then you take 5 steps and you walk over here. And then you take 5 steps, well, you end back where you started, right? You end up exactly back where you started. Okay, let's say I want to add a bigger number. Let's say I want to add 20. And I'm going to add negative 23 to it. Okay, this number kind kind of big, right? Like our number line, we can certainly shrink the scale, right? We can say, okay, this is like, let's say this is 20 now. But counting 20 steps, that's pretty tiring, and we don't want to count 20 steps each time. And also, what if I had an even bigger number, right? What if I had a number like 100 or 1,000, right? We don't want to count 1,000 whole steps just to do an equation. And maybe we have 1,000 plus -2, right? We don't want to count 1,000 whole steps and then get another 2 in there. So the second method we can use is called using the absolute value. My chalk. Absolute value. Remember in the last video, I did talk about absolute value. Just as a quick refresher, absolute value just means you take the magnitude or the size of whatever is in here and you just ignore the sign. You take the sign away and basically when you have no sign, it's just positive, right? So we can have absolute value of donut equals a donut. We can have absolute value of -17. That's just 17. It doesn't matter what we put in here. We can literally have anything we want. We can have absolute value of banana. That is just equal to banana. If it's negative banana, it's still banana. So when you're working with absolute value, basically just look at the size of the two numbers being added. Let's look at our example again. 1,000 plus -2. Well, clearly we can tell 1,000 is much bigger than -2 in terms of size, right? Like 1,000, the absolute value of 1,000 is equal to 1,000, and the absolute value of -2 is just 2. So what happens here is we just subtract the absolute value of them, right? So remember, we performed some operations that look like this. The absolute value of 1,000 minus 2. What is this? Well, if we have 1,000 things and we take away 1, that means we have 999 things left. And if we take away another 1, that means we have 998 things left. So this is equal to 998. Yay! So, after taking the absolute value, we just look at the sign that has the number that's bigger, right? And by bigger, again, I just mean the size. So, the size of 1,000, the absolute value of 1,000 is much bigger than the absolute value of -2. That means we know for sure the number will be a positive number. So, therefore, we can just say, okay, this is equal to 998, like so. So that is the case for when two numbers have different signs. You just look at the number that has a larger size or a larger magnitude, and you say, okay, let's just take that sign, and we plug it over, and we perform the subtraction for the absolute values, and then, ta-da, our answer. Okay, now what if our signs are the same? What if we have -3 plus -5? Ooh, this is too small. We can use a number line for this. So what if we say -300 plus -500? Something like that. Well, in this case, it's the same sign, right? So what do we do here? Well, we just simply add the absolute value of it and keep the sign. We just keep this, right? So we have 300 plus 500. And how do we do that? Well, we could do this. We just 0 plus 0 is 0, 0 plus 0 is 0, and 3 plus 5 is 8. So we get 800. However, the next time you see two numbers that look like this, oh wow, you're just like, okay, 0, 0. That means you know for sure these will obviously be zeros, right? So we just have to add this. So we get 800, like so. And remember, it was a negative sign. So therefore, -3,000 plus not 3,000, negative 300 plus negative 500 is just equal to negative 800. Now I think this one is a little bit more tricky than just simply using the number line. So let's do a few more examples. Okay, let's do negative 32 plus 20. Okay. Well, after looking at the absolute value, we look at the magnitude, right? So which one has the bigger magnitude? Is it negative 32 or negative 20? It is negative 32, right? Because if I have 32 things, let's say I have 32 donuts, and my brother has 20 donuts, then that means I have more donuts than my brother. However, thinking about it like this, looking at a number line, everything that's negative is over here. Everything that's positive is over here. So 20 is somewhere here, and negative 32 is somewhere here. That means on the number line, negative 32 is actually smaller than negative 20. Huh. So remember, magnitude and the actual value or the actual size of it is not really the same thing. And by size this time, I know it can be a little bit confusing, but by size this time, I mean literally like the literal size of it, right? Like how far to the right is it on the number line? Okay, back to the problem. Okay, so we have determined that negative 32 has a larger magnitude, the larger absolute value. Then we know for sure, okay, whatever the answer will be, it will be a negative. So now we can just perform subtraction. Let's do the absolute value of 32 minus the absolute value of 20. Right, this is just equal to 32. Well, let me write it here. 32 minus 20. 2 minus 0 is 2. And 3 minus 2 is 1. So the answer is 12. And we just stick it right back here. And don't forget the negative. So the answer is negative 12. Now let's do one last example. And then we'll move on to subtraction. Okay, let's do 70 minus 20. Plus. I almost got ahead of myself there. Okay, 70 plus negative 25. The chalk. So, once again, let's look. Which one has a bigger magnitude? It's 70, right? The number 70 has a bigger absolute value than the number 25. Now, in this case, it just so happens that 70 is also bigger than negative 25 as a whole, right, on the number line. 70 is here, and negative 25 is here. Okay, so let's perform subtraction on the absolute values. So the absolute value of 25 is just 25. The absolute value of negative 25 is just 25. So 70 minus 25. What do we do here? There's nothing. There's got to be minus 5 from nothing. But you tell me now. We have something here to use. So we just take 1 and we carry it over. And this becomes 10. So now 10 minus 5, right? Let's say I have 10 donuts and I take away 5 donuts from that. We get 5 and 6. We have a leftover 6. 6 minus 2 is simply 4. So now we have the number 45. And remember, which one is bigger? 70, right? So the final sign of 45 is positive 45. Now, we can say a positive, but if it's invisible, then it's always positive. Okay, great. I think we can move on to subtraction now. So if we have two numbers, let's say 2 minus 4. So this is called the difference. This is called the minuend. And this is called the subtrahend. The subtrahend. So, minuend, subtrahend, difference. Again, nobody really uses the words minuend and subtrahend, but if you want to sound fancy and cool, you can use them. But we do use the word difference quite a bit, and we also use the word sum a lot too. So yeah, minuend is simply the number here, and then subtrahend is the one you're taking away from the number. Okay, back to the question I just had on the board. 2 minus 4. Oh, what do we do with this? Because, 4 is bigger than 2, right? So how do we get that? Well, once again, we can take a look at our number line. So let's go from 2. 1, 2, 2 steps. And then now, remember, left is moving in this direction, right? The negative direction. So let's go 1, 2, 3, 4. And we end up at -2. So we get -2. So again, we can use the number line always. It's very nice to see visually, but even for me, I think for me, after seeing something visually, it does make a lot of sense in my head. So we know that addition, or adding something, is the opposite of subtraction, or taking something away. So, another way of thinking about this, right, if you don't want to draw the number line, and think about it that way, another way of thinking about it is simply these two are opposites of each other, right? So we can take any subtraction problem and just switch it and flip it into an addition problem. So back to our problem here, 2 minus 4. Well, minus 4, this is actually equal to 2 plus -4. So this one, it doesn't make too much of a difference because after using the number line, we pretty much use the same method, right? So basically we just went from 2 and then added 4 in this direction. So what I did just now, right? Turning this 4 into and plusing, ooh, this was a minus in this. Actually, no, I should just write it out, yeah. 2 minus 4, turning that into a addition problem, right? 2 plus -4. I was taking something called the additive. Okay, I was taking something called the additive inverse. Again, this is just a really fancy way of saying the opposite, right? The additive inverse is just the number you get to get the number back to 0. So the additive inverse of 4 would just be -4, right? Because we have to take 4 steps. We have to take, -4 steps, if you think about in that direction on the left. -4 steps to get all the way back to 0. So let's apply this opposite in this flipping, turning subtraction into addition. Let's try some problems. Okay, let's do 7 minus 8. We kind of did a very similar version of this. So, again, we could use a number line, but hint, let's try a different method. Let's turn this into an addition problem. So we take the opposite of this, and the opposite of, we want to turn this into a positive, right? So this, we just put the positive, the plus sign here, and we'll just keep the -8. Right? Because, I'll get into this in a little bit actually. Maybe next time. Yes, definitely next time. But basically, as you can see from here, 7 minus 8 is literally just equal to 7 plus -8. So how do we solve this problem? Well, this has no sign, so it's a positive. This is negative, right? And which one is bigger? 8 is a little bit bigger than 7, right? So we know for sure our answer will be negative. And now we just take subtraction. 8 minus 7 equals to 1. We put 1 down here, and we know it's negative 1. Let's do a few more problems. Negative 7, negative. Oh, I shouldn't do 7 again. Let's do 14. Negative 7, negative 16. Okay, so when you see a negative sign, you don't have to do too much to it, considering the opposite thing I mentioned earlier. You can just do negative 14 plus itself, right? Like so. And this, right, they have the same sign, so we're just adding the two of them together. And we know the final answer will be a negative. So 14 plus 16, 4 plus 6 equals a 10. We carry the 1. 1, 2, 3, that is 3. So it would be negative 30. Okay, one last example. So let's do negative 25. Actually, no. Positive 25 minus minus 30. Okay, so now we're back to this problem, right? It's kind of weird to minus a bigger number from the small number, right? However, we can turn this into 25 minus 1 plus minus 30. Okay, so now we can see this is positive, this is negative, so different sides. And we can see that 30 has a larger magnitude than 25, so we know our final answer is negative. So 30 minus 25. So we take one of the ones from here. This guy becomes 10. 10 minus 5 is 5. 2 minus 2 is 0. So we just get negative 5 as the answer. Yeah, and that's pretty much adding and subtracting positive and negative whole numbers. Oh yeah, like I mentioned in the very beginning, whole numbers just means, right, we have no decimals. And yeah, we'll talk about decimals and fractions in a later video. But yeah, thank you so much for watching, and I hope you enjoyed this little exploration of human numbers as usual. This is Donut, signing off.